All right, another handy test is what's referred to as you're looking at two different elements or two different responses, and you're seeing whether or not there is a difference in the mix of responses. And a way to do that, you may have remembered from your statistics courses using a Chi-Square test. So if we were interested in looking at for example, maybe the product mix of one store versus another store to see if there was any significant difference, we could use a Chi-Square test to evaluate that. So what we're going to try to do here today is we're going to talk about using a Chi-Square test to evaluate product mix differences between two stores. All right, so that's really what we're going to look at. And I wanted to go in and say, okay, which two stores do we want to pick? Maybe pick a couple of stores, maybe in different counties. So I went up and I took a look at, this is the Lincoln County demographic information for 2020. And the last page of this has our store listing. So we have the different counties, and I want to pick out a couple of different stores from a couple of different counties. So we've been using in a lot of this statistical work is stores 34 and 76. Well, they happen to be in the same county. So let's take a look at maybe one of these stores in Tribeca County, and let's compare it to another store, maybe, I don't know, in Thomas County. So maybe we look at store 34 and store 33. So we'll look at 33 and 34. So let's focus on that, or we can look at a different county, but let's try 34 and 33 and see what the difference between those two counties. So go back to our scripting here, and so what we're going to do is we are going to examine the differences in product mix across two counties by examining a store in each county. All right. Now, this may not tell us anything. We might have to look at, are there demographic differences between the two counties? May have to do a little bit more digging. So let's start by getting our data in here. So let's put in all of our import pandas as PD. We want to import NumPy as NP. We want to import SciPy. Let's see. Oh, import. Make that sure that's an M. Okay. We want to import from SciPy.stats. We want to import Chi-Square. Also from SciPy, we want to import stats. And probably put that ahead of our bringing the SciPy there. Beautiful. Okay. And I think that's all the importing we want to do. So let's run all of these just to make sure I don't forget to do it. All right, now we want to read in our data. So I've already set my working directory. We're going to still use the June sales. So let's bring in sales is equal to pd.read CSV, and what we want to read in is sales final 6/30/2021.csv. We want to change the sales date. I just like to do this. And we want that to be PD2 date time. And we are changing sales, and we're changing the sales date. Okay, and I'm going to read in a new data frame. And if I look at my files here, the data frame I want to bring in is this classification data frame. Now, if you try to read this one in, it doesn't read in. There's some problem with the CSV file. So I redid it, and you'll also see this other one called PY Classification 2021. If you are interested in learning how you can actually get this read in and done, and this is exactly what I did. I read in this file and changed it and saved it as this file. I'm happy to share that code with you. All you gotta do is ask. So I'm gonna read in, we'll call this data frame class, and that's gonna be pd.read_CSV. And what we want to read in is PY classification 2021.csv. Okay, I think I got that spelled correctly. So I'm going to run these. And while that's running, and we'll take a look at what's in class. Because I want to try to bring, I don't want to look at every single brand, because that starts getting really small, and you've got a lot of individual categories to compare there, and you may sell none of some product, and so it just gets something a little bit more aggregated. And so I don't want to just go with wine versus liquor. I'd like to maybe do something based on its classification. So if I look at classification, there's lots of different classifications in here. And you can see class name American whiskey, it all has class numbers 100, and these are all the American whiskeys. So if I wanted to see if there was a product mix difference, I might want to combine American whiskey, Tennessee whiskey, blended whiskey, and see if there's a difference in bourbon whiskey, if there's a difference in product mix based on the classification name, just to kind of evaluate that. If I wanted to even break this down more, I could probably start recoding or come up with a code that says if it's whiskey, give it this number. If whiskey's in here, give it this number. If we keep going down, we got all sorts of different whiskeys, so all those whiskeys could go together. Scotches could go all together, right? So if you want a single malt whiskey, on and on and on. So there's lots of different kinds of bringing together of this stuff. But I thought what we do is based on the class name and try to bring this all together. And you can see brand is the link between the classifications and our sales data. Okay, so first thing we want to do is we want to merge the sales file with the classification file, because I want to get that class name and class number in there. So what we're going to do is we're going to come up with sales merged, and that is going to equal pd.merge, and we're going to merge sales, and we're going to merge class. And how we're going to do that, I would like this to be just an inner join. Okay, if there's something that is in my sales file but it's not in the classification, it's probably not going to be big enough to make a difference. Right? My big categories are likely going to be contained in there. And we're going to do this on the variable brand. All right, so that's my sales merge. So I'm going to run this, and I'm going to see a new data frame pop up here called sales merged when that finally finishes. And the two stores we wanted to look at stores 33 and 34. So we want to also do a query out of this sales merged file for the test, right? So we'll call this sales test. And what we're doing here is we're doing sales merged dot query. Remember back to doing this, and we want store to equal either 33 or 34. Okay, just like that. So now this will give us just the sales out of the sales merged for the two stores 33 and 34. So let's run that, and we should end up having a much smaller sales test with 638,000 records in. Okay, well then, we're doing some merging, we're doing a query to get a smaller version of this, and now what I want to do is I want to create a crosstab table that accumulates everything based on class name and store. All right. So what we're going to do is I'm going to create what's called a contingency table. I'm just going to name it contingency. And we're going to use a new way to accumulate data. We've done pivot tables, we've done aggregate functions. What we're going to do here is we're going to create a crosstab. So we're going to do pd.crosstab. And what we're doing is we're going to take sales test, like that. And we want the things that are in the rows to be class name. So class name is going to be in the rows, and in the columns I want sales test, and in there I want store. Okay, so I'm pulling out those two variables, and I want, remember, it's rows, columns. So this is they're going to have these rows in class name and this in columns. So if I run contingency, what this is going to do is it's going to give me the sum of all of the items that are in here. That's kind of the default. It's going to give me the sum. If I want to get the mean, what I need to do is I'd have to put in here some function called mean, right? So I probably do, if I wanted the mean, I think I can put in, let's see, what does it tell me? I would have to do a little bit of research, but my guess is I just put in by mean. But this is just going to basically sum all of these things up for me, and that's what I want. I could probably put in some kind of way to normalize this by percentage, but I really do want to take a look at the full amounts, because what you see here is American Dessert, 1 versus 2 bottles. I don't really care, right? 6 bottles here versus 276 bottles. Okay, so that's a big difference, but is it really that big of a difference given the sum total of everything that they sold? Well, we're going to find out. So because these two stores likely sold different amounts of liquor, right? We can do that pretty easily. So I'm going to do np.sum. And what we want to do is we want to do np.sum of contingency. And we want, say, 34. And so we're going to look at the total sum of sales of that is 420,000 bottles. If I also wanted to find out how many bottles we sold in 33, we can run that, and see how many bottles we sold in store 33. Here I sold half as much. So if I just did a chi-square test based on these total numbers here, I would get a positive outcome because I'm not selling as much. And how much is the chi-square test actually telling us about the product mix versus just the difference in the total amount that they sold? So what I want to do is I want to take this and potentially put it into percentages. I might also want to, and this is a decision, I might also want to look at, some of these smaller amounts, right? So maybe I want to look at anything where I sold more than 100 bottles. So I'm going to actually subset this, right? So I'm going to take contingency. I'm going to keep it the same. And I do this in 2 steps just because that's just the way I like to do it. Contingency. And I want to see where contingency for 33 is greater than or equal to 100. And I'm going to do the exact same thing with 34. And I'm going to run those consecutively. I'm just going to change that to 34. I'm going to change that consecutively and keep my eye on how many items I drop here. So right now I have 108 different categories. I'm going to run the first one. I dropped quite a few, right? So 33, which happened to be the store I sold the least amount in, I dropped a bunch of categories where I sold less than 100 bottles, right? 100 bottles is not going to make that big of a difference to your product mix. I'm also going to run this on 34 and see if I drop any more. I dropped one more. So overall, you got to have a minimum of 100 bottles sold in each one of these categories to be analyzed. All right, that's good. Now what we want to do is we want to change these numbers, right? I can use these numbers and do a chi-square test on it. But I think it'd be better because we're looking at different sums, right? If I rerun these, we'll see what the sum changes are. So still have 416,000 bottles sold in 34, and I still have 216,000. So I didn't get rid of that much in sales. But because they're so different, I really want to give this, what's the percentage of sales? What's the percentage of sales that you're doing? So what we're going to do is we're going to create contingency, and we'll call this PCT, percentage, and that's going to equal contingency. Yep, divided by contingency dot sum. Okay, so what this should do is it should go through contingency, and if we did a little calculation here, if I took 716, this is store 34, divided by 416, 694, and let's bring that up here just to see, make sure that this thing does what we want. So I can take 716 divided by 416, 694. So I should get a percentage of 0.001718 when I run this line. So let's see if that's true. So I'm going to run this line here to turn everything into a percentage. We're going to look at contingency percentage, and store 34, Amaretto American, I should have, when I did my calculation, I should have 0.00171829. All right, so at least, again, I always like to double check, make sure that what I am writing here as far as code is concerned is doing what it's supposed to be doing, right? That's just my very cautious way of looking at this stuff. So now what I have is I have percentages, right? And you can look and say, well, on a percentage basis, maybe there's not a lot going on here. I mean, you can look at the different colors popping up here, and okay, so 10 versus 12, almost 13%, 7 versus 8, here's 8 versus 6. Are these really statistically different? Are these product mixes statistically different? Well, let's actually go through and do and I'll do the test a couple of different ways. Let's just do test equals chi-square. And we'll do contingency PCT. And another way of doing it is, and we'll call this test 1, is stats dot chi-square underscore contingency. And we're doing a contingency table on contingency PCT. Okay, so these are two different tests. I want to make sure I have contingency. I got that right. Chi-square. What's this telling me? Undefined name. Contingency percentage. Contingency. PCT. It should be fine. I think I did this right. Contingency. Let's run it. Let's see what it says. No, it's not liking that. It's not defined. Oh, I've got the N. That's why. Oh, my spelling errors. Let's try this again. So we're going to run this. And I'm also going to run test 1, right? So I'm outputting the results into these tuples, if you will. So this one, it tells me that it's a chi-square test of around 2.21, and the p-values are not significant. So what this tells me is that overall, the product mix between stores 33 and 34 is not different. And we can look at test 1, and this is just a different way of presenting it, right? So here we've got the chi-square. This is the chi-square statistic. This is the p-value. 74 is the degrees of freedom, and then these are the predicted amounts that would be in here. If we could look at this, if this would go all the way down, you'd see it have 75 different items, and you can actually open that up and see these are all the predicted amounts that you would see for each one. And you can see they're coming up with, this is obviously they're doing a comparison of these predicted amounts against what is actually happening there, and it's not statistically significant from 0. So that is a way to do a chi-square test. Now, if you ran this with the non-transformed into percentages, and we ran this on just the contingency table. So what I'm going to do is I'm going to take out underscore percent and just run these tests again, but run these tests with just the aggregate amount. We can look at test, right? It starts becoming significant, right? Because you're also looking at just differences, all right? And if I look at this one here, again, it becomes a significant statistic, right? Because there are differences in the aggregate amounts between these two. Versus when we're looking at percentages, the product mix as a percentage of total isn't really all that different. But because of the size of the stores, or the amount of activity in each store, well, obviously the product mix is different. It's statistically significant. No, the reason why is because we've got difference in how many items we are selling in each store.